Hi students, how are you? Here is an interesting question. The major product formed in the following reaction. So, what product will be formed? Here the compound is treated with sodium hydride, this is a strong base, then carbon disulfide and methyl iodide. So, we will follow the sequence. First, we will draw this compound in chair form. Let's say the isopropyl group is at this position. This will be in equatorial position because if it is in axial position, then it will face severe 1,3 syn diaxial interaction with this 1,3 hydrogen, and the methyl group is at 4 position and OH group is in this position. If it is treated with sodium hydride, this is a strong base. It will take this proton and it will turn the OH into O minus. Now it will react with carbon disulfide. As sulfur is more electronegative than carbon, it will be delta minus, it will be delta plus, and it will act as a nucleophile, it will act as a electrophile. So it will attack to the carbon center. So O C double bond S minus. Here will be a CH3 isopropyl group. Now it is treated with CH3I. CH3I. So S minus will attack this CH3, I will eliminate. So it will be this compound. Now it is heated. It is heated at 200 degrees centigrade. If it is heated at 200 degrees centigrade, what happens, student? It will syn elimination reaction will occur. Syn elimination. It will take one syn beta hydrogen. Here there is a hydrogen, here also there is a hydrogen, here is one hydrogen. So it will take this hydrogen because this is in downward direction and this hydrogen is also in downward direction. So these two are in syn position. So this sulfur will take this hydrogen with this pi bond. It will not take this or this hydrogen because these are far away from this group. So in these cases, these are thioester. In these cases, if a thioester is heated, then syn elimination, it is actually called the pyrolytic syn elimination reaction will happen. So what happens, student? This pi bond will capture this hydrogen. This bonded electron will be shifted to this carbon-carbon to form the double bond. This bond will break to form the CO single bond. So what happened? Here the isopropyl group is as usual. Here the CH3 is as usual. Here they will form a double bond plus C double bond O SH SCH3. So this will be the product. Here is another reaction. If this compound is treated with potassium hydride in THF, what will happen? This is also an example of elimination reaction, and it is also a very important reaction. It is a decalin compound, and as the hydrogen and the OH group in trans position, so it is a trans decalin derivative. So first we'll draw this structure in chair form. So hydrogen is here above, which is below OTS. This is above OTS. Now if this is treated with potassium hydride, it is a strong base, sorry, it will be negative. This is a strong base. The hydride ion will take this proton and it will form O minus. This will turn O minus. This is OTS. Now what happens, students? Here see one thing, that this bond and this bond are anti-periplanar to each other. These bonds and these bonds are anti-periplanar to each other. So what happened, if O minus will form this pi bond, this bond displaces the OTS group from backward direction. So here also an elimination reaction will occur. So the product will be sorry here there is a pi bond, here there is a oxygen. So in this case this is trans, so if we draw in another form, then the product will be the oxygen is here. Now we'll count 1 2 3 4. At position 4 it will be in trans. So 1 2 3 4. At position 4 it will be in trans. So this compound will be the answer. And another similar type of reaction sometimes gives in different competitive examination, like this. If a cis isomer is given, that is cis decalin, same reaction sequence, then what will happen? The major difference is this is trans isomer, this is cis isomer, where hydrogen and OH are in same. It is cis decalin derivative. So I will draw the geometry. So OTS is here in upward direction. Here the hydrogen is below the plane, which is below the plane. In presence of hydride, it will take this proton. This boundary electron will be taken by oxygen. this will be O minus, OTS is here. Now see one thing, here this bond and this bond are anti-periplanar to each other. So what happens, student? If the O minus will form this pi bond, this bond will displace the OTS group from the backside and elimination reaction will happen. So here we will draw this. Here there will be a pi bond, there will be double bonded oxygen. If we simplify this structure, this is double bonded oxygen. 1 2 3 4, at 4 position there will be a pi bond which have cis orientation. So 1 2 3 4, this is trans, so 1 2 3 4, the double bond will be here. Here this two group has cis, 2 hydrogen. So students, you can see that these two reactions are of similar type. One is trans decalin derivative, whereas another is cis decalin derivative. From this cis isomer we are getting double bond in cis position, double bond which has cis configuration, whereas in this compound from trans decalin we are getting trans isomer, double bond has trans composition. So if you have any doubt regarding this question, please let me know in comment box, and to get such interesting videos, subscribe my channel. Thank you, have a good day.